Good scientific afternoon. Welcome to McScience GCSE support. I am Andy, and I today will be taking you through the starting of some support for your GCSE work. Now, this support can be applied to any of the exam papers. It can actually even go across to other subjects as well. And if you apply this knowledge that we start to go over today, you'll start to understand how easy it is to actually achieve well in your science exams. Hello to everyone that has joined so far as well. Much appreciated that you have come along today. And hopefully we can start to break some things down for you and start to help you work out where to go next. So what we're going to do is just share my screen with you so that you're able to see what I'm looking at. And with this, my whole goal of this series is to literally help you out in any ways. So if at any point you have a question and you're not quite understanding what I'm saying to you, or you want something elaborated a little bit more, just let me know. This is a live session where I literally am here to help you in any way possible. So at the minute, as you can see, I've got a whiteboard down the left side for a bit of information, and then I've got a exam paper. Now, just for ease today, I am going to show a AQA past paper, and this might be that you're AQA, it might be that you're Edexcel or OCR, but in general, they all follow the same process, the same skills, the same information. They just sometimes write their exam questions slightly different, which isn't necessarily a bad thing or anything like that. It just is their preference. All right. So let's get looking at this. So this is a paper one chemistry. It's the 2023 exam paper. And with this, we are looking at a foundation paper starting off. So with us looking at a foundation paper, as you go through the questions, they generally get harder, and you would start off with multi-choice, like one-word answers, things like that, and then they will start stretching you to higher level questions or higher information. Now, with this, before we do anything, I'm showing you some exam questions here already, but what I want to do is actually break this down first of all so that you know how to actually correctly tackle an exam question. Now, I have spoke to students from heavily from the Plymouth area, but also from across the country, and one of the first things they say is that their teacher says, answer all the questions and kind of leave you to your own devices. Or when it comes to revision, they say, go home, do some revision, watch some YouTube videos, as you might currently be doing. And with this, you again are kind of left to your own devices. Now, what I'm going to do today is actually help guide you. And if you follow the process that I show you today, you will start to see an improvement and things increasing, and your knowledge actually being accessible to apply to these exam papers, which is a key thing in a lot of situations. So, let's get started on what I want you to do. Now, we've got a whole load of information on this paper, first of all, and our first actual step is skip the info. You'll have to apologise for the handwriting. Um, so you're going to skip the info first of all. So we're not even going to look at any of this up here. We're going to go straight to the question. Now, the second thing that you will do with this is actually look for the command word. Now, I literally had a session today where I asked my students, I work at City College Plymouth, if you don't know. I asked my students today, what is a command word? And wherever I've actually been, again, this is one of them things that it's kind of automatically assumed that you know what a command word is and what they're actually telling you to do. And one of the biggest things, if I can get you to comment for me now, are you do you know the difference between describe and explain? So if you can comment now for me and just tell me if you know what the difference between describe and explain is, that'd be amazing. And I will look at anyone's answers in a minute as you write them. The third thing that you then need to actually do, so when we're looking at this, our command word is actually what. What we then need to actually move on to is how many marks it's worth. So marks wise, for this first question, we've got 2 spaces and we've got 2 marks. Therefore, we would be expecting just a mark per word in this scenario. We read the question. So what is the number of protons and the number of neutrons? So that is our step 4. So number, because I've actually read the question. So what is the question? Is our next part. Then I want you to look at the info. We're then looking at info. What you are then actually, and I apologize about my handwriting, it is one of them practice makes perfect thing, and hopefully as we go through this series, it will get better. Your next step is your answer. So obviously you're going to write your answer, and your final step, which sounds strange, but you're actually looking at time/reflection. Now, what you're doing with this reflection time is actually taking the total amount of exam time that you're given to actually go over these answers. So you might look and be able to say instantly the number of protons are and what the number of neutrons are with really any difficulty, if you will. And with that, it might take you just 20 seconds. Now, in general, for a GCSE, you are actually looking at anywhere but, well, normally a mark a minute. And with being a mark a minute, you might finish in 20 seconds. You've still got a minute 40 left on this question. Now, what you're then going to actually do is come back to the question at the end. Now, I've heard this statement time and time again. I remember it when I was in school. I remember it being a teacher at times, and a teacher will say to you, once you've completed the questions, go back through your answers. And I have watched it. I have been the person doing it. And you kind of just flick through the pages and are like, yeah, I'm all done. I'm all good. That will do. Now, what I actually want you to do with that time is reflect. And I want you to ask yourself why. Why did I look at that command word and why did I write the answer that I have given? With this, you can then start to think, reflect, and hopefully boost your marks straight off the bat. So we haven't actually even really looked at questions as such, but we've looked at how we can expand and how to actually tackle these questions correctly. Now, this is one of these things that I have got my students to do in the past, time and time again, and it works. I've never known it not to work, even with my private tutoring that I do and the tutoring company that I work for as well. Um, when I've explained this process to them, they've said, this has actually cleared up a lot of information for me. So when the first hurdle of, well, how do I approach this exam, they've been able to actually say, well, actually, this style is helping me out a lot more. This thought process has actually helped me know where to go next. All right. So, with this question, what is the number of protons and the number of neutrons in beryllium? So, protons and neutrons are only found in the nucleus of our atom. So, with it, a proton has a positive charge and a neutron has a neutral charge. So, for this actual question, we'd be looking at the four positives, giving us then four protons and five neutrons in that center. Now, what we would then do is obviously move on to our next question. And again, just like before, we are going to go straight to where the command word is, which again is a what. Following our process, our mark is the next thing. So it is just one mark. Then we look at the question. So what is the relative charge, sorry, not relevant, relative charge of a beryllium ion? Now, this is a perfect time if you sit there and then go, well, I've got no clue. This is a perfect time to then go to your periodic table. Now, again, what we can do is a couple of very simple things here. So on the periodic table, we've obviously got the numbers along the top, and beryllium is located here. And for beryllium, it's in group 2. That means it has 2 electrons in its outermost shell. Now, with having 2 electrons in its outermost shell, what we're able to then understand is that if I, like all metals, lose them 2 electrons, I'm losing negativity. And with losing negativity, I would be able to become more positive. And if you think about it as a situation where every single atom on this periodic table is all neutral, they have the same amount of electrons as protons, what we then have is that understanding of neutrality. And when then we take away negativity, we become positive. And you can even apply that to real life as well. So, again, if you would like to comment at all in the live chat, hoping it's active. I believe I've done so. Do you think then, if I lose 2 electrons, would I be +1 or +2 overall in my charge? Then, when we start to go further into the question, and obviously, if you want to pause it there and have a bit more of a think, if you're watching this, thank you very much for the answer. It would be +2. I can't fully see your name on there, but yes, you are correct. You would be right with +2 because we've lost 2. So well done for answering that. Much appreciated for the comment. Whereas we then start to move on. Now, this is one of these kind of questions again. We've got a whole load of information. We've got a whole load of pictures. Let's skip it. Let's find the command word. there's our command word is what. We're 1 mark. Let's read the question. What state of matter is represented by state C in figure 3? So obviously then we have to look at the information. We then answer it. And again, would anyone like to answer it? If not, I will answer it for you. Try and actually see if I can see the live chat a little bit bigger. So what state would C be? Now again, pause now if you are wanting to look at this, or if you're watching it back later on and you're wanting to go over this question. But the answer here would be a gas, because the particles are spread out. And we could also, on this diagram for the gas, is draw actual lines behind them showing that they're going in random directions and at random speeds as well. Whereas our solid here in A, they're in neat rows. They're all touching, organized, vibrating around a fixed position. Our liquid, now this is one of these things that unfortunately, because it is a two-dimensional image, we can only draw it in a certain way. Now, liquids are like solids in the sense of they're all touching. So where we've got on here, for example, zoom us in, where we've got these big gaps in between, they wouldn't be there at all. All the particles should be touching, but it's just the diagram that we use to represent this. And they're able to move freely like our gas, but they always remain touching. And with them remain touching still, they have obviously more energy, and we go from there. So moving us on to question 1.4. And again, you can see how exam papers start off on the foundation. The higher is slightly different. And with the question we've got here, again, the command word is what. We've got 1 mark there. What is the name of the process when state B changes to state A? Now, I would say again, this is where you would obviously look back at the information provided, because B to A you might forget. So we've got a liquid becoming a solid. So what would that be? And again, pause now if you are wanting to watch this back later on. If not, can anyone tell me what they think this might be? And again, I do want to just say again, thank you to everyone that's watching at the minute and those that have participated in answers. So would we be condensing, freezing, or melting if we were going from B to A? So with this, we would be freezing, and we can also refer to this as another word as well. And if you think you know the other word beginning with S that we would use, again, please comment for me. I would much appreciate that. But I'm going to leave it as freezing, and that will be a little extra question that I will get you lot to answer for me. So moving on. Again, we got the command word. How can state B be changed into state C for 1 mark? And when we're looking at B to C, we've got more energy. Therefore, for it to get more energy, we have to be able to look at where it's getting it from. And in general, to get that energy, we heat it up. So we would then look at heat for our answer. And they've given you 2 lines, but I mean, you can write that as a full sentence, or you can literally just put heat. Obviously, it's better if you write it in a sentence to some degree, but the markers are only looking for the word heat. They would also allow you to say evaporate or boil. And obviously, evaporation and boiling are two separate things as well. Now, I do want to just take us um, into a few other things as well. Now, as you know, each exam board does vary slightly, and for a lot of you, you will have mocks coming up soon. Now, I'm going to show you the AQA spec first. Now, this is one of these things where, again, you're kind of guided to do it on your own accord, but without much actual um, guidance in the sense. Now, I've spoke to again number of students over time, and with this, one of the biggest things that they struggle with is actually knowing what's going to be in each exam. Now, in this situation, the paper one and paper two biology exams for AQA contain topics 1 to 4, and paper two is 5 to 7. So our topics 1 to 4 is cell biology, organization, infection and response, and bioenergetics, whereas the paper two is homeostasis and response, inheritance of variation, evolution, and ecology. And this is something that you are able to look at if you're an edXL student or an OCR, if you go onto their website, you can look at the exact information that's going to be in your exam that day. And this is one of the biggest things where I will, for example, have students come to me saying that they've got mocks coming up. And with them mocks coming up, they don't know what to study. And this is one of the first things that I always recommend doing is actually going to the actual exam board and looking at what the specific units are that they're going to ask you for. So we can then see here we've got chemistry paper 1 and 2. So atomic structure, periodic table, bonding, properties of matter, quantitative chemistry, chemical changes, and then our paper two, whole different load of questions. And then physics is exactly the same. So we've got energy, electricity, particle model, atomic structure, forces, waves, magnetism, electromagnetism in the paper two. So when you are going through the exam period, you can actually then target your revision to these specific things, target your revision to these specific question types. Now, this is exactly the same whether you are doing higher or foundation in regards to these units, and it's the exact same amount of time. The only variation is your grade boundaries. And one of the things about your grade boundaries, so if I just again choose AQA as what I'm looking at, one of the biggest things a lot of people don't realize is actually how little a grade amount of marks overall you need. Now, this is, as you can see, a lot of different exam papers, and it will vary per exam thing. But if I was looking at AQA trilogy, for example, one of the first things is it's out of 420 in total. So that's all 6 papers, all added together. And with that, when you're, and again, you can go to edXL or OCR and find these grade boundaries as well for last year's exam papers. And if you go through each actual grade boundary, you'll recognize that it's always around the rough similar amounts. So with this, for the June 24, what you can notice is you only, for 420 marks, you only need 266 in total across all of your papers to get the grade 5. So that is just over 50%. Now, obviously, if you are a higher student, I want you to notice there that you only need 289 marks to get the grade 9. So a lot of people like panic that they have to be getting like 80, 90% on the exam paper to get a grade 5 or get a grade 9 if they're a higher student. And it's not the case at all. When you start to actually break it down, you start to understand that actually reality, you're 50% or less. So the grade 4, for example, the grade that most colleges, most um, courses at a next level would want, um, you are just over 50% of the marks. So 225, you're looking at about 30 marks each. Now, the great thing is about the combined science or the Synergy combined science, or if you're at Excel, they just call it combined science. The great thing about these is if one of your papers is extremely weak, but your other 5 are really strong, they balance out and it's all added together still to get that grand total. Whereas if you are a triple science person, it is slightly different. For example, physics here, as you can see, and there are a whole range of actual GCSEs out there. You can see that it's out of 200 because you'd have the 2 papers that you'd be expected to do, and you would then only be able to get the grade 5. You would need 136 out of 200, so about 60-ish marks per paper, and so on from there. I am going to leave it there today. I want to just say thank you to you all for coming along to this video, answering questions, liking this post. If you can share as well going forward, that would be amazing, and let others know, because this will make a big difference for you going forward into your exam. As always, like, share, comment below, and I'll see you on the next video. Bye.